Okay, in this one, another simplex method. Try to set up the initial simplex tableau. How many slacks do you need? Well, it depends on how many messes you make, really. But in this problem, you need 3 because you have 3 functional constraints. All right, pause the video, see what you can do. You don't have to have the blank tableaus down there. Again, just saving time on my end. You might ask, how do you know how many pivots you have? You don't. There is I think there's a formula. I never technically learned the formula, so I really can't tell you. It's generally around the number of negatives you have, but you might create more negatives as you go, or you might knock out 2 negatives at a time. So that's sort of how you want to think about it. There might be 2 in here because there's 2 negatives, but that's not always going to be true. Okay, let's determine the pivot element. We need to start off with the pivot column. So the most negative number in the objective function row is -2. So this must be our pivot column. We'll take the positive entries of the pivot column and divide them into the right-hand side. So 9 divided by 3 is 3. 4 divided by 1 is 4. And 12 divided by 1 is 12. 3 is the smallest ratio. So that means this is our pivot row. I'm doing a terrible job. So we need to turn that 3 into a 1 and everything else in that column using the pivot element into a 0. So we'll say 1/3 row 1 becomes row 1. Negative row 1 plus row 2 becomes row 2. Likewise, negative row 1 plus row 3 becomes row 3. And 2 row 1 plus row 4 becomes row 4. All right, put that tableau into your calculator as a matrix and do those 4 operations, and then come on back to make sure you get the same answer. Okay, so this is the matrix we have now. We are not done, and we know we're not done is because there's still a negative in the objective function row. So we need to repeat the process and find the pivot column. Well, there's only 1 negative, it's -1/3, so that must be the pivot column underneath x sub 2. And if we divided 1/3 into 3, we get 9. 2/3 into 1, we get 1.5. And 9 divided by 3/11, I'm pretty sure is bigger than 1.5, which means that the second row is now our pivot row. That scales it. That doesn't really shrink it. That's okay. So that means this, I didn't circle my other number. Why didn't I circle my other number? There we go. So that means this 2/3 is our pivot element. So we'll need to multiply that second row by 3/2 to turn it into a 1. And assuming it's a 1, we'll do -1/3 row 2 plus row 1. We'll do -11/3 row 2 plus row 3. I'm getting squishy there. And we'll do +1/3 row 2 plus row 4. Blah, 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 try it, blah, 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 pause the video. Okay, so let's make sure you got the same thing. And since there are no more negatives in the objective function row, that means we are done. So we can read across. x1 is basic. Ooh, I made an arrow this time. So x sub 1 is 5/2. X sub 1 is 5/2. And then x sub 2 is also basic, so read across. X sub 2 is 3/2. We don't care about what the s's equal, so we're going to ignore the s sub 3's value. Z is 13/2, again, reading across. So the ordered pair in this case that optimizes our optimal solution, I should say, is 5/2, 3/2, and our optimal value is 13/2.